What I'm going to discuss is about moving loads with alternate solution using influence line. So, a truck or other vehicle rolling across a beam or girder constitutes a system of concentrated loads at fixed distances from one another. So, ang distance between loads, fixed na siya. Load 1 to load 2, fixed ang distance. Load 2 to load 3, fixed po ang distance. So, pag ang beam gani, acted by concentrated loads, dali ra mag-solve o dali ra mag-draw sa shear o moment diagram. So, kung mangita ka o maximum moment, dali ra sad. And based on yung illustration, kung i-draw niyo ang moment diagram man uh, positive man so upward, and then positive po upward, negative downward, and then downward. So it's obvious na ang maximum moment is dere. It's under P2. So, uh, what makes this one easy is mas dali ra it's easy to identify the location of the maximum moment. And it is always under a particular load. It could be under P2 or under P1 or under P3. So, dili mahitabo na ang maximum moment is in between loads. It is always under a particular load. So ang problem to karon is where to locate these loads that will produce maximum moment on the beam. So in general, the bending moment under a particular load is a maximum when the center of the beam is midway between that load and the resultant of all the loads then on the span. Okay. You have to master this one. Okay. Bale, if you want to get the moment under a particular, as I have said a while ago, a maximum moment sa beam with concentrated loads will always be under a particular load. Di ba? So, kung saan na to pagkuha sa, kung saan na to paglocate sa load, inani sa. The bending moment under a particular load is a maximum when, this is what you will do. When the center of the beam is midway between that load na gikonsider nimo and the resultant of all the loads then on the span. So, ang center sa beam daw, ipatunga nimo in between that load ngayon consider and the resultant of all the loads then on the span. Ang pasabot sa then, tanan nga loads nga naa sa span. Outside the span, walay apil. So like this one. Natay duha ka loads 40 and 60 and using Vergnon's theorem, mo na so assuming nadi ang resultant 3 meters from 40 kilonewton na load and 2 meters from 60 kilonewton load. So, sa kanina illustration, yung kanina figure, gi-assume siya na ang maximum moment under ani na load, under sa 40. So, kanina itong gikuan o kuan, maximum moment. So, ang gibuhat is, ang center sa beam, gipatong nga between 40 and R. The distance of 40 and the resultant is 3 man. So, midway, na ang center sa beam. That is why, from the center of the beam to the 40 kilonewton load, natay 1.5, 1 half sa 3. And from the center of the beam to R, 1.5 also. So, by doing this, nalukit na nato ang 40. We all know nga ang 40 na diyan 1.5 meters to the left of the center. So, since 10 na siya, and then 3.5 ni. So na-locate na nato. Once ma-locate ang isa ka load, pwede na nato ma-locate ang uban nga loads. Kaya fix man ang distance sa mga loads. Yan na. So kung saan pagkuha sa moment under sa 40, uh, use beam analysis. Get the reaction R1 or R2. After that, you can use diagrams, shear and moment diagrams, or you can use method of sections. Cut kasi dire. Then you get the moment at this point, mao na dayon. So ang problema lang dire is ang locations ng loads man. And mo ni ang buhaton nimo. Yan na. So, with this rule, we compute the maximum moment under each load. Each load ha. So, i-test na to ang 40, i-test po na to ang 60. And each load, natin makuha ng maximum moment. Maximum moment under sa 40, maximum moment under sa 60, and so on. So, of all the values, mo ni ang kuan. Use the biggest of the moments for the design. Usually, the biggest of these moments occurs under the biggest load. Usually ha, so there's a chance na dili sa correct. Not at all times man. So ang pinaka-safe ana is kung ahato natungod ang resultant, katong loads nga nearest, katong duha ka loads nga nearest sa resultant, mao lang to ang i-test nimo. Like kung naa kay 5 ka loads na nasa span, and then ang resultant is in between 2 and 3, 2 and 3 ra ang i-test nimo. Ayaw na i-test ang 1, 4, o 5 to save time because it is assumed na ang maximum moment under sa 1, maximum moment under sa 4 o 5 is smaller as compared to the maximum moment under sa load 2 or 3. Okay, pero if you want to follow this one, nga the maximum moment occurs under the biggest load, pwede ra. Pero to be safe, i-test lang nimo sa duha. Kay usually mo ni, so there's a possibility nga wala sa biggest load, kundi sa nearest nga load niya. Depende lang. Pero in this case, it's obvious na ang resultant is nearest to 60. Mas dako gining 60 kaysa 40. So, ayaw na i-test ang 40. Marabag, automatic ang maximum is smaller as compared to this. Pero kung ang resultant is, let us say, 1.5 meters from 40, 3.5 to 60, it could be na ang maximum moment is under 40 and not 60. Depende lang. Mga nasa na to be safe, i-test ni mo ning duha. Inana buhaton. But still, nakasave kag time, kay dili man tanan nimong i-test. Okay. For the maximum shear, it occurs at the reaction where the resultant load is nearest. Like in this case, pero ang idea is, the biggest load should be placed over the support. Kini one setup na siya. The other setup is ang 10 is over the left support. Pero ang distance sa resultant from the left support kay 5 man. Whereas dire, ang distance sa resultant to the right support is 3 only. So, na dire ang correct na setup. And the biggest shear is this one, the value of R2. Maximum shear. Because if you'll notice, sa shear and moment diagrams, the biggest shear is located at the support. And normally, it's equal to the value of the reaction. Mana siya nga ang maximum shear, kung sa value sa reaction, mo ito ang maximum shear. I'll be solving two problems only. So, this is problem number 1. A truck with actual loads of 40 kilonewtons and 60 kilonewtons on a wheelbase of 5 meters rolls across a 10 meters span. Compute the maximum bending moment and the maximum shearing force. So this is the beam, 10 meters, mo itong loads, 40 and 60. Distance in between is 5 meters. So, first, ilocate ang resultant using Varignon's theorem. Similar sa katong centroid of composite area ba? Area total x bar equals area 1 x1 plus area 2 x2 and so on. In this case, force ta. Total force or resultant times x bar equals F1 x1, F2 x2 and so on. And then, depende na lang sa imo reference either sa 40 ba or 60. Sige, let us use 40 as our reference, no? The resultant is 100, 40, and 60. So, mo ni siya. 100 times x bar equals F1, 40, distance is 0. Kaya na-add ng reference. Plus 60, and distance niya is 5. X bar is 3. Ano, di ba? Okay, so, although short ang resultant is nearer 60, the biggest load, pero for demonstration purposes, i-test na to ang 40 para ma-compare na to and makita kung if indeed mas smaller ang value sa maximum moment under 40 over sa 60. Assume maximum moment occurs under the 40 kilonewton load. So, this is the center of the beam. Take note, the distance between R and 40 is 3. Okay. And then R and 60, it's 2. So, 3 man to, ay patungan na to, half of 3, okay, 1.5, 1.5. So, na dali ang 40, and then ay remaining distance na 3.5, 3.5 pod. So, na ito 60 diya, 2, so natay 1.5 dire. There is a 3.5 pod. So, kung ano itong moment na, we solve for the reactions, R1 or R2. Okay. Let us solve for R1. Let's sum up moment at 2. Okay. And we have R1 equal to 35. Okay. Another option here is, instead na individual loads, imong ano moment like 40 times 6.5 plus 60 times 1.5. Pwede ra na resultant instead na individual loads. So, bale, you replace these terms by resultant 100 times 3.5 tapos minus R1 times 10. And you will get the same value of R. And this is very helpful if you have so many concentrated loads. Kung daghan kaayo ba, ah, pwede rin siya. Makasave kag time. Mas dali rasad. Okay, so after this, cut section sa 40. Okay, you may include 40. Pwede ra po dili, no? Kay magsama po tag moment. So it will not affect our solution. Kung na 40 diya, so pwede ra wala. So sa akong moment, it's 35 times 3.5. It's 122.5. Ana. And the next, let's assume that the maximum moment occurs under the 60 kilonewton load. Okay, the distance between R and 60 is 2 man ba? So tag 1, 1 dire. So 3 dayon Natay available na 1 dire pud 5. Sorry, 4 5 minus 4 and then 1. And since 60 itong 1, 60 itong diri nga moment itong kaan, pwede ra R2 itong isolve. Depende lang sa imo. Okay, so let's sum up moment at 1. We have R2 equal to 40, or again, instead na individual loads, pwede ang resultant. 100 times 4. Ano yun? And you will get the same value of R. So, after this, cut kag 60. Okay. Again, pwede rin sa wala 60, kaya dili siya maka-affect. And then, summation of moment, 160. Okay. So, i-compare nimo sa kaganina, under sa 40, it's 122, while under sa 60, it's 160. So, indeed, mas dako sa. The maximum moment is 160 kilonewton meter. Okay. Maximum shearing force. Remember the technique. You place the load over the support, leftmost or the rightmost load. Okay, so first setup 40 over the left support. The other setup is 60 kilonewton over the right support. And you solve for the reactions. Depende lang. This is very easy. Yeah. Sa kag moment sa 1, of course, 40 times 0, 60 times 5, R2 times 10. Very basic. Yeah. And then summation of force sa Y, R1 equal to 70. We can use Caltech here if you want. Pero para para maka-learn mo sa basic, yun, inanira. Okay. Ayan na lang ng Caltech pag master. So, second setup, 60 over the right support. R1, R2, and then summation of moment sa 1, makuha ang R2, 80, and summation of force sa Y, makuha ang R1. And i-check nimo, out of the 4 values of R, the biggest is 80, therefore the maximum shear is 80. Okay. That's for the first problem. Second problem, a truck and trailer combination crossing a 12-meter span has axle loads of 10, 20, and 30 kilonewtons, separated respectively by distances of 3 and 5 meters. Compute the maximum moment and maximum shear developed in the span. Okay, 12 meters loads. First, locate the resultant. Again, use Barre-Ignon's theorem. So, resultant 10, 20, 30, so 60. Na diretong reference 10 times 0, 20 times 3, 30 times 8. Ano siya? And then natin x bar equal to 5. Kana, no? Okay. So, the resultant is nearer 20 than 30, no? The distance of R and 20 is 2 and 3. But the biggest load is 30. So, you have to choose asa ang maximum ano, 20 ba or 30. So, if you are not sure, i-test ni mo ito. Okay. Dili na lang ang 10, kaya obviously, ang maximum moment under 10 is smaller compared sa 20 and 30. Okay. So, under 20, the distance between R and 20 is 2 meters man. So, nakay tagwan. And then 3. Mamuna ito x bar, 5. And then malocate na to ang 30. And natay remaining distance rin nga 2 kay 6 man eh. Kuha na tong moment ang 20. So, solve the reactions R1, R2, R1 na lang. Summation of moment at 2, makakuha na itong R1. R1 equals 25. Okay. Or, kani, no? So, ang moment sa 2. Instead na tulo, resultant lang, 60 times 5. Kani. And R1 equals 25. And then, katog section sa 20, analyze the left portion, mao ni siya. Hanap kang moment, then you get this. M equals 95 kilonewton meters. And then, assume maximum moment occurs under the 30 kilonewton load. The distance between R and 30 is 3 meters. So, tag 1.5 sa. So, nadiyang R, nadiyang 30. And then, 3 man. And then, R and 22 man. Now, we only have this distance. Now, 6 minus 1.5 minus 2. 2.5 ang available. But the distance between 20 and 10 is 3 man. 2.5 minus, so 3 man isa. Therefore, we cannot proceed with our analysis because the resultant nga 60 is not correct because the total loads on the span is only 50. Diba? Dahil sa 60. So, even if you will replace this one by 50 and not 60, wrong hapon because ang location sa resultant, which is 3 meters from 30 or 2 meters from 20 or 5 meters from 10, kanang allocation is based na sa computation, based na itong Varigno's theorem, assuming na ang tulo ka loads nasa span. But in this case, duhara man, wala naman ang 10. So what we will do is, i-relocate na to ang resultant, considering two forces only, 20 and 30. We will exclude 10. So ani ang buhaton. We have to relocate the resultant because the total load on the span is only 50 kilonewtons. So ang pag-relocate, kini natin consider 20 and 30 and x bar is 3. Referred sa 20 na. Kana. Pero ang i-test na to is only 30 na. Dili na ito mabalik sa 20 because na-prove naman nato sa 20 nga ang 10 is still on the span. So okay na itong 20. Ang 30 lang. Kini na itong gamitin karon. The distance between R and 30 is 2 meters. Mo na itong gamitin. Kani na. And then, natay clearance na 5. The distance between R and 20 is 3 man. Kana, so safe ba? Natay 2 dire, natay 5 dire. Ang kuha na ito moment ani, and we solve for R2. So, R1, R2, sa moment sa 1, makakuha ka R2. Or, resultant, 50 times 5. Ano? So, muna yung R2, and then cut ka, moment, muna yung reaction, di ba? And na kay 104.167. I-check na ito sa 20. Ang moment under sa 20 is only 95. So, mas bigger siya. Indeed, correcto ka ganina na the maximum moment usually is nasa katong load, biggest load ba. And since the biggest load is 30, nadari ang maximum moment. Pwede ra, kung moditso ka, if you want a direct solution, feeling nimo na di ang maximum, okay lang. Pero if you want to be safe, i-test nimo ano para safe ka. So the maximum moment is 104.167. The shear force, same lang. You place the leftmost load over the left support. First setup. Second setup, you place the rightmost load over the right support. And solve for the reactions. R1, R2. Depende ha. Pwede ra R times 5, 60 times 5. Depende lang. So R to 25, summation of force, 35. Second setup, 30 over the right support. And R1, R2, summation of moments of 1. And then summation of force. And check dayon. For values, 25, 35, 45, 15. The biggest is 45. Maximum shear force. Okay. That's it. That's it for moving loads na style. No? As discussed in the mechanics of deformable bodies, yung natura, no? Pero sa theory, structural theory, under the topic of influence lines, pwede natin siya i-solve using influence lines. Okay. So, mao ni siya. We will use the same problems. Ha? So, for problem 1, mamana ba ito problem 1, di ba? Uh, so, this is for maximum moment under the 40 kilonewton load. So, dili ta magkuha og moment. So, for influence line, dili siya ta mag-cut. Ana siya. So, ini-cut na to. We all know nga ang influence line, i-rotate na counter, i-rotate siya clockwise, inani ato influence line niya. Triangle. And then this distance is 3.5, and then this distance is 6.5. And the value of this one, ordinate niya is A times B over L. So, 3.5 times 6.5 divided by 10. Mao ni siya. 2.275. And then, you place the loads. Kana, 40 o 60. Distance of 5. So, natay 1.5 diha. To solve for the ordinate, kini y value niya, ratio and you can use ratio and proportion, or pwede rad na get the slope first, 2.25 divided by 6.5 times run dayon mo na yung rise. Kaya slope is rise over run. So to solve for y, it's slope times x. So nakuha na yung slope daan, 2.275 over 6.5. Slope to times x mo na yung y. 0.525. And the moment under 40 is equal to magnitude of force times ordinate, 40 times 2.275, 60 times 0.525. 122.5. And under the 60 kilonewton load, 1 og 1, dili ta mag-cut sa 60. Dili ta mag-cut. So muna to influence line. And this one is 6. And this one is 4. And the value of this is 6 times 4 divided by 10, it's 2.4. And then you place the loads, 60 and 40, with a distance of 5, so natay 1 dere. So to get the ordinate under 40, slope na sad ta, 2.4 divided by 6, slope times x natay y, 0.4, and then moment there. Magnitude times ordinate, 160. Okay, this is the same value nakuha na to using katong deformable bodies na style or solution. And for the shear, maximum shear, Kuha na to influence line ano yung support. Bali, you may not solve for the value of R1 and R2 yun. Nga kato summation of moment or summation of X o summation of force sa Y. Instead, influence line dito. So the influence line of a reaction is using Miller-Birch law. I-push na nimo upward and mana siya. One din siya. And then loads 5 ni 5 po ni dire. And kuha mo ordinate. Pero 5 og 5 man, automatic ang ordinate ani 1 half po sa 1. So that's 0.5 set. Mo ni ang shear 40 times 1, 60 times 0.5, 70. And second setup na dering 60. Kini pud nga reaction atong kuhaan og influence line. So i-push po na nato upward, then Miller-Birch law mo na atong displacement curve 1, and then loads 0.5 po ni by ratio and proportion. And mo na itong shear 80, di ba? Mo na itong maximum 80. For the second problem, this one, okay? I-test na to sa 20, 20. So, dito mag-cut sa 20, mga to influence line. So, 5 ni, 7 eh, and 5 times 7 divided by 12, mo niya, 35 over 12. Ibutan na to ang loads, 20, distance of 3, 5. Natay clearance diri na 2, diri po 2. So, get the ordinate of this. You can do a ratio and proportion. No? Pwede po slope pa, rise over run, slope niya times horizontal, mo na imong vertical. And there is slope, rise over run, times horizontal, and you have this. And moment, magnitude times ordinate, magnitude, ordinate, magnitude, ordinate. This one, you have 95. And under 30, yan again, nilapas man itong 10, di ba? So, that is why you have to relocate R. Inana. So, X bar is 3. Trohon mo. Mo na niya karon. And then, moment ka dahil sa 30, sa influence line, dira ka mag-cut, mo ni may influence line. So, 7 5, A times B over L, 35 over 12, and then loads ni mo, 5, naka-clearance na 2, and then ratio and proportion or slope, tayon times x, na kay y, sorry, na kay 5 dali, na kay y, and then compute na yun. Magnitude, ordinate, 104.167. So, to check, ang maximum sa 20 is 95, whereas sa 30 is 104. So, mo na itong maximum. And for shear, draw kag influence line sa left support. Ana, 1. And then place the loads, 3, 5, 4. Mada yun, 1 divided by 12, slope na, times horizontal, distance times horizontal, 9, and mga. Or if you want to use ratio and proportion, okay ra. Kung convenient ka, kung convenient sa imo to, pwede ra ta. Bale, 1 is to 12 equals x or y is to 9, shift solve, mo yung kuha nyo. Magnitude times ordinate, magnitude, ordinate, magnitude times ordinate. 35 siya. Second setup, another 30. And then you draw the influence line of the right support. And then you place the loads. Same lang, no? Um, ratio ano person, mani makuha nyo. And then magnitude ordinate ito. And comparing the two values, the maximum is 45. Okay, so that's it. Ang mao lang to ang kuan nito, ang i-master nimo ang pag-play sa kuan. Katong idea about central line na midway siya between that load and the resultant. Kato lang, no? If ma-master to nimo, then okay lang. Yeah. Dali ra man mag-analyze sa moving loads. And then pag naay mo lapas na load, mo to ang buhaton nimo. I-relocate nimo ang resultant and then redo. Ay, i-place balik, i-test na po di mo balik. And then select the biggest value na tayo. Uh, so I hope that you have learned something. Thank you for watching.